Hello and welcome everyone in the new lecture video of Theory of Computation. In previous lecture video, we have discussed about finite automata and the different ways for representing finite automata. In this lecture video, we will study about one of the type of finite automata, that is deterministic finite automata. Let's get started. A deterministic finite automata, DFA, is a mathematical model of automatic machine which consists of set of states and a deterministic control that moves from one state to another state based on the input symbol and state. Here the deterministic controls means the movement is fixed. That means for a particular input, let's say A, and state, let's say Q, it always moves to some fixed state, let's say R. That is, it have no choices. We can also say that its control is already determined and DFA can't be more than one state at any time. Now let's define DFA formally. Formal definition of DFA. It is a finite automata which consists of 5 tuples M equals to Q sigma delta Q naught F, where Q denotes set of states, sigma denote input alphabet, delta denotes transition function which takes state and input symbol as a input and produce new state or same state as a output. This transition function defines the movement of automatic machine. Let us suppose initially the machine is in state Q0 and switches to state Q1 after reading a symbol 0. Now this movement can be represented by using the transition function delta as delta of Q0, 0 equals to Q1. This means the machine switches to state Q1 after receiving input symbol 0 in state Q0. The next component is Q0, which represents the starting state, and the final component is F, which represents final or accepting states. Remember, while constructing a DFA, you should define transitions for all input symbols from each state. We will discuss on this later on. Let's clearly understand the formal definition of DFA by taking an example. The state diagram in above example represents DFA, let us denote with M, that consists of following 5 tuples. As we know, the first tuple is Q, which is a set of states. In above state diagram, the set of states are Q0, Q1 and Q2. And the next tuple is alphabet, that is set of input symbols. In the above figure, there are 2 input symbols, 0 and 1. Similarly, the next tuple is delta, which denotes the transition function and used to represent the movement of the above DFA, and is given as, since in the above figure the input 0 into the state Q0 switches to the state Q1, so we write del of Q0 comma 0 equals to Q1. Similarly, delta of Q0 comma 1 equals to Q0, since the input 1 in state Q0 does not change its state. Similarly, when the input 1 is given in the state Q1, then it switches to the state Q2, so we write delta of Q1 comma 1 equals to Q2. Similarly, delta of Q1 comma 0 equals to 0. Similarly, delta of Q2 comma 0 equals to Q2, and delta of Q2 comma 1 equals to Q2. These are the transitions of the above DFA. The next tuple is Q0, which denotes the starting state of DFA. So in our above figure, the starting state of DFA is also Q0. Similarly, the next tuple is F, that denotes the accepting state, and in the above figure the double circle state is called accepting state, and which is Q2. Here Q1. Now this is the state diagram of DFA. Since here we define every transitions from each state for all input alphabets. That is, we define where to go from state Q0 after receiving 0 and 1. Similarly, we also define where to go from state Q1 after receiving 1 and 0. Similarly, we also define where to go to the state after receiving 0 and 1 in the state Q2. As I told you, in DFA, we have to define all transitions from each states for all input symbols. Now let's find the language accepted by this DFA. For this, we have to first find the set of strings that are accepted by the above DFA. The pattern of these strings are then analyzed to find the language of DFA. But how we know a particular string is accepted or rejected by the DFA? For this, we must have a knowledge about how a DFA processes a string. While processing the string, the DFA reads the symbol of the string one by one from first symbol to last and changes its state according to transition function. After reading the last symbol of the string, if it reaches to the accepting state, then the string is considered as accepted, otherwise considered as rejected. This is how any string is processed by the DFA. Let's take an example. Take an string 1 0 0 0 1 0. to process this string in above DFA. Initially the DFA is in state Q0. From Q0 state it reads the symbol 1, which leads it to the state Q0, and then it reads the symbol this 0, which leads it to the state Q1. Then it reads the next symbol 0 from Q1 and it changes its state to Q1. Similarly, it reads the next symbol 0, which does not change its states, so the state is Q1. Similarly, it reads the next symbol 1 from state Q1 and moves to the state Q2, and after reading the final symbol from the state Q2, it reaches to the state Q2. Here we can see that after reading the last symbol of the string, that is this 0, the machine is in the state Q2. So this whole string is considered as accepted. Let us take another example. 1 1 1 0 0 0. To determine whether this string is accepted or rejected by the above DFA, we have to process this string. Here the initial state is Q0. In Q0 it reads the symbol 1, which leads it to the state Q0, and from Q0 it reads the next symbol and the state does not change, so Q0. Similarly, from Q0 it reads the next symbol 1, still the state remains same, Q0. And from this Q0 state it reads the next symbol 0, which changes its state to Q1. Similarly, from this Q1 state it reads the symbol this 0 and the state does not change, hence Q1. And from this Q1 it reads this symbol last, that is last symbol, and the state does not change, so here we write Q1. So as we see, after reading the last symbol of this string, whole string, the final state of the DFA is Q1, which is not accepting state. That's why this string is rejected by the above DFA. Now let's find other strings which are accepted by the above DFA. As we see, the string 100010 is accepted by the above DFA. Similarly, the string 01 is also accepted by the DFA. Since reading 0 input symbol into the state Q0 reaches to the state Q1, and then reading 1 leads it to the state Q2, which is a accepting state. Similarly, the string 101 is also accepted. Since reading 1 from the state Q0 remains in the same state Q0, and then reading 0 from this state leads to the state Q1, and finally after reading the 1 from Q1 leads to the state Q2, which is final state. That's why this string is also accepted by the above DFA. Similarly, the next string is 11011. The next one which is accepted by the above DFA is 1001110, and so on. Now, seeing all these strings, one thing is common in all the strings, that is, in every string the 01 substring is present. Here 01 exists, and in this string 01 exists. Similarly, in this string 01 exists, in this string also 01 is exist, and in this string also this substring 01 exists. So we can say that the language of above DFA is set of all strings composed from alphabet 0, 1 and have 0, 1 as a substring. Now, to formally determine whether a particular string W is accepted or rejected by the DFA, we have to compute delta cap of the initial state Q0, W. If the output of this is accepting state, then the string W is accepted, otherwise rejected. This delta cap is called extended transition function, which defines the movement of DFA after reading the whole string W from state Q0. The only difference between delta and delta cap is delta have two parameters. First one is state and another is input symbol. In the case of delta cap also have two parameters. One is state and another is string. Therefore, we can write delta cap of Q0, 0, 1, 0, 1. This is valid. But delta of Q0, 0, 1, 0, 1 is not valid, since delta receives only input symbol as a second parameter, but this is a string. Similarly, delta cap of Q0, 0 is also valid, since in this case this 0 is a string of length 1. Let's formally define the extended transition function, which is useful to compute delta cap of Q0, W. The definition of delta cap, that is extended transition function, is given by the help of induction on the length of input string. So we have two steps. First one is basis step. In basis step, we define how to compute delta cap if the string is of length 0, that is epsilon. That means how to compute delta cap of Q, epsilon. As we know, reading nothing in any state does not change its state, so delta cap of Q, epsilon is Q. This is the basis step. In induction step, we define how to compute delta cap of Q, the string W, where W is of the form XA and this A is the last symbol of the string W. In this case, we can write delta cap of Q, W equals to delta of delta cap of Q, X, A. That means first we have to find where to go after reading the string X from the state Q, and from that state we read the next last input symbol, that is A, which is our final state. That means we have to first find the state that reaches by reading the string X in the state Q, and then from that state we have to read a symbol A, which leads us to the final required state. Let us suppose the machine reaches to the state P after reading the string X in the state Q, that is delta cap of Q comma X equals to P. Then delta cap of Q comma W equals to delta of P comma A. Let's compute delta cap of Q0 comma 1 0 1 0 0 1. Here this whole is W. So we can simplify this as delta cap of Q naught comma 1 0 1 0 0 comma 1. Since delta cap of Q comma W equals to delta cap of Q comma X comma A. Here this is A, that is the last symbol, and this whole is X. Again we simplify this by using inductive step. Hence delta cap, now this is A and this remaining is X. So Q naught comma 1 0 1 0 comma 0 1. Again we simplify this term by using inductive step. So delta of simplifying this, we require one extra delta, and then delta cap, this is X and this is A. So Q naught comma 1 0 1 and this is A, so we write 0 and then these terms 0 1, which is equals to, similarly we simplify this, and delta cap, this is X and this is A. So Q naught comma 1 0 comma 1 and then these. Which is equals to delta of now in this case this is X and this is A. Delta cap of Q naught comma 1 comma this is A, so here we write 0 and then these, that is 0 1 0 0 1 equals to del of now expanding this by using inductive step, here we can write this one as a epsilon dot 1. This epsilon is nothing, it is a string of having length 0. So we can write del cap of Q naught comma epsilon, this one is X and this is A. So here we write 1 and these symbols equals to del of del of del. Now the value of this is q naught. Since delta cap of q naught comma epsilon is q naught, so here we replace this term by using q naught. So q naught comma 1, and then these comma 0 comma 1 comma 0 comma 0 comma 1 equals to these terms, that is delta and this delta. Now to compute this delta of q0 comma 1, we see the transition function, that is in above state diagram, reading a symbol 1 in the state q0 remains in the same state. That means delta of q0 comma 1 equals to q0. So we replace this value by using q0 and then these terms 1 0 0 1 equals to, similarly we write these delta of this. Now computing this value from the above state diagram gives delta of q0 comma 0 equals to q1, and we write these symbols, that is 1 comma 0 1, which is equals to delta of then computing this, that is delta of q1 comma 1 by using the above state diagram. Here we see reading 1 in the q1 state leads to the state q2, so this whole is replaced by q2, and these 0 0 comma 1 equals to delta of now this value, reading 0 in q2 leads to the state q2, so here we write q2, then these equals to delta of, similarly this transition, that means reading 0 in the state q2 does not change the states, hence we can replace this by using q2, then this. Finally, reading this one in the state q2 still remains in the same state, that is q2. So after reading the last final symbol, that is this one, the whole DFA reaches to the state q2, which is accepting state. That's why this string is accepted. That's all in this lecture video. If you have any questions, then leave the comment below, and please like, share and subscribe this channel. Thank you for watching this video.